Okay, chapter 4 review from 4.1. All right, so tell me what you get when, with this equation, f of x equals 2x cubed plus 6x squared minus 3. And tell me what you get when, what you get for f of negative 3. Go. All right, so f of negative 3, when x is negative 3. Okay, so you just plug it in. Oops, that's cubed. So negative 3 to an odd power is negative, so that's negative 27. And 6 times negative 3 squared would be 9. So 6 times 9. And then 2 times negative 27 is negative 54. Plus 54 minus 3. Those cancel out, leaving negative 3 as your answer. We got that right. Yay. Boo. Alright, let's go on. Let's see. How about 4.2? Let's do some long division. Oops. And what are we going to do long division on? Let's see here. How about f of x equals 3x cubed minus 5x squared minus 4x minus 8, and divide that by 2x squared plus x. Okay, 2x squared plus x, and then 3x cubed minus 5x squared minus 4x minus 8. So all you do is you take the first 3x cubed over and divide by 2x squared, okay? So the first divided by the first. So 3x cubed divided by 2x squared. What do you get?
3 over 2.
Yeah, you get 3 over 2x. All right, so that goes right here. But you have to distribute that through this. So everybody do that real quickly. And we get 3x cubed plus 3 halves x squared. And then we subtract. And the first thing cancels out. And 3 halves is 1.5, so that's 6.5. So negative 6 and 1/2 x squared. Drop down the next thing. And do the process all over again. So I would change 6 and 1/2 to negative 13 halves. All right. So negative 13 halves x squared divided by the 2x squared. First divided by the first. Okay. So obviously the x squareds cancel and we're left with negative 13 halves over 2. So you take the top, negative 13 halves, times the reciprocal of the bottom, and that gives you negative 13 fourths. Okay, so you take negative 13 fourths and distribute it through the 2x squared plus x. So do that and then subtract, please. All right. Distribute that through, you get negative 13 halves x squared minus 13 fourths x. Okay, so when we subtract, changes all of that. That cancels out. 4 over 1. You got to get a common denominator, so you multiply it by 4, top and bottom. So that's negative 16 plus 13 would be negative 3/4 x minus 8. So, are we done? How do you know when you're done doing long division? When you get to right there, right? So this is our remainder. So I'm asking you what the remainder is, and that's what you would tell me. Okay. So I'm looking for all of that on the test. So you should be writing down how to do that if you didn't remember what to do. All right. All right. Synthetic division, please. Oops. All right, let's see. Which one do we want to do here? How about f of x equals negative x cubed plus 4x squared plus x, and c equals negative 2. Go ahead and use synthetic division and tell me what you get. Okay. Negative 1, 4, 1, and 0. Negative 2 goes there. Drop the first one down, multiply. Add, and multiply. Add, and multiply. Add. That's your remainder. We got 22. Just to show you that you're doing it right, it's the same thing as saying that from problem number 1. So negative 2 cubed plus 4 times negative 2 squared plus negative 2. See what you get when you plug negative 2 in for x. All right, these are just coordinates. If it's a 0, that means y is 0, right? So these are x-intercepts that we're looking for. So if it's not a 0, that doesn't mean that what you're finding doesn't work. It just means you have a point that's on your line, but it's not on the x-axis. So that's negative 8, and you have negative in front of it. That's positive 8. That's positive 4, so that's 16. So you get 24 minus 2 is 22. I mean, it's an actual coordinate that you found.
So if you kept going and dividing by -2, would you eventually get a 0?
No. This proves that it is not a 0. All right. Now let's go on. Find a polynomial of degree 3. So this is 4.3. It's degree 3. What does that mean?
3 zeros.
Yep, got 3 zeros. There are the 3 zeros. And also, when x is 2, I get negative 36. All right, so first of all, begin the process of finding the equation. All right, so they come from this. X plus 4, x minus 3, and x minus 0. All right, so technically that's what we're looking for. Now, continue from there. I want to know what the original equation was. Okay, so the second part of this is finding your leading coefficient. You could put this in the equation now, or you can put it in after you combine all of this. It doesn't really matter. Okay, so what we're saying is, how do you find A? So if we plug in x and y over here first, it doesn't matter when you plug it in. Okay, you'll get the same answer. So negative 36 is y, x is 2, and that you can quickly figure out what A is. Okay, so 2 plus 4 is 6, 2 minus 3 is negative 1, 2 times 6 is 12, that's negative 12A. So what is A? Positive 3. Okay, so now you have f of x equals 3 times x plus 4 times x minus 3. And let's just distribute. I'm going to go ahead and do these last two first. It's just a preference, that's all. So that's x squared plus x minus 12. And then distribute from there. And that would be your original equation. All right, moving on. Let's go with finding all the solutions. If I give you enough solutions, you got to find the rest. Find all the zeros. And let's do f of x equals x to the fourth plus 7x cubed plus 13x squared minus 3x minus 18. Now I want all the zeros. There's 4 of them. I'm going to give you 2. Negative 3 is 1, and it has a multiplicity of 2. So there's 2 of your zeros. Begin. So let's start with synthetic division. You do it again because it has a multiple of 2. Okay, so now what do you do? Who knows the next step? Will? Yeah, you got to factor, you have x squared plus x minus 2 here. And that factors into, wow. What?
X plus 2 x minus
Yep. So what are all the zeros?
1.
Yep, we got 2 negative 3s, a negative 2, and a positive 1. All right, so we'll just continue with this problem. I'll give you a separate problem than this one. We're going to graph it. First of all, what does it look like? Yep.
Are both endpoints going to be facing up?
Yep. Because you have a positive leading coefficient, and it's an even exponent, it's parabolic opening up. All right, so let's go ahead and kind of, what else do we know about this? So we know the end behavior looks like that. What else do you know by the equation?
Crosses the x-axis 4 times.
Crosses the x-axis possibly 4 times. It doesn't always cross the x-axis because it has 4 zeros. You could have imaginary zeros, remember, which means they don't cross at those values. All right, but these are all real numbers. So we have our x-intercepts there, right? What else? What about the y-intercept? Do we know that? What? Negative 18. It's always the number by itself. Okay? So let's go ahead and graph all of this. All right, so we won't be very accurate on this. We have negative 3, 1, 2, 3. We have a negative 2, and a positive 1, and a y-intercept of negative 18 down here. Okay? So here's our end behavior. At negative 3, what are we doing?
Going through.
How do you know if you go through or if you touch it? Multiplicity of odd values. So it's even because it has 2. So it touches, but then it's got to come right back down and go through at negative 2. The next point is the y-intercept, and then the next point is going through 1. Okay? So that was something like that. All right, let's do graphing of f of x equals, this is 4.4, I think. Graph for me, nope, I'm sorry, 4.5. F of x equals negative 3 over x plus 2. All right, begin. All right, so since the top exponent is smaller than the bottom one, okay, there's no x in the top, y equals 0 is my horizontal asymptote, okay? You probably can't even see that on the board, can you? So the x-axis is an asymptote. All right, so we typically start with x-intercepts and y-intercepts. X-intercept, set your numerator equal to 0, except there are no x's there. So there's not any x-intercepts. Y-intercept, set x equal to 0, and we get negative 3 halves. Okay. Vertical asymptote, what is that? Set your denominator equal to 0, x equals negative 2. So we have an asymptote at negative 2. And then horizontal asymptote we've already done. And now it's graphing. So we don't know if it's above or below in the second or third quadrant, so we have to plot a point. Let's put in negative 3. So negative 3 over negative 3 plus 2 is negative over a negative, which is positive. So our graph looks like this. And since we have a y-intercept down here, we know we are in the fourth quadrant. Not the first quadrant, but in the fourth quadrant. So we just graph that. And that's the graph of that. That's how long that should take. Hopefully you've gotten faster at these. All right, let's do another one real quickly, and then we'll be done. All right, let's do f of x equals x plus 4 over x squared minus 4. Okay, I'll give you 1 minute. I'll just do it. We're running out of time. X-intercept is at negative 4. Y-intercept, set all your x is equal to 0, and we get negative 1. And vertical asymptote is your denominator, zeros, so x minus 2x plus 2. That's the difference of squares. So x equals 2 and x equals negative 2 will be your asymptotes. And horizontal asymptote, what do you notice about that? The top is smaller than the bottom, right? What does that mean? Yeah, y equals 0. And oh no, we have an x-intercept at negative 4. What does that mean? Well, let's look at the inside here. The middle part has to look like this because there's no x-intercepts from negative 2 to positive 2. We can do the right side by getting a positive or negative, so let's plug in a value and figure it out. Plug in 10. 10 plus 4 is positive. And 10 squared is 100 minus 4, that's positive. So we know we are positive after that line. How about we plug in negative 3? Negative 3 plus 4 is 1. Negative 3 squared is 9 minus 4 is 5. So at negative 3, we're at 1/5. And then you should plug in a negative 5. I'll go ahead and do that. You guys go ahead and take off. Negative 5 plus 4 is negative 1. And 25 minus 4 is 21. That's negative. So something's happened here. It must do this. All right, so let's continue with the graphing stuff. I want everybody to graph this equation. So f of x equals negative 3x squared minus 3x plus 6 on the top, and x squared minus 9 on the bottom.
I'm confused. I'm confused.
What's the problem? To get your x-intercepts, you set your numerator equal to 0.
For some reason, I thought you put the zeros in for x.
That's for the y-intercept.
But I don't know what to do left now.
Hey. Okay, so now I'll do the vertical asymptote, which is the denominator, which that's the difference of squares. So at 3, 3 and negative 3, all right, and horizontal asymptote. Your leading exponents are the same. So that would be y equals negative 3 over 1, or y equals negative 3. And you notice the middle part's easy to do here. And so will the left part and the right part. Left part, there aren't any x-intercepts here. And the right part, there aren't any x-intercepts. So that means the lines have to be in these open areas. All right, let's do one of these, all right? How about we do f of x equals 2x squared minus x minus 3 all over x minus 2. So x-intercept, y-intercept, vertical asymptote, horizontal asymptote, and then graph it. All right, x-intercept, 2x squared minus x minus 3 equals 0. So that's 2x minus 3 and x plus 1. So your x-intercept's at 3 halves and negative 1. Y-intercept would be negative 3 over negative 2 or 3 halves.
Also,
Vertical, x equals 2. Horizontal asymptote, top exponent's bigger than the bottom one, so you must do long division. How do we do long division, everybody? Take the first divided by the first. There's no video on the test.
so it'll be 2x.
So the answer would be 2x. So 2x goes here, and what do? We have to distribute it through. Now what? Subtract. Now what? take the first, divided by the first. Oops, that's just x, which is 3. You can stop right there. You don't even have to calculate it out. So that's your slanted asymptote. So it goes through at 3, and it goes up 2 and over 1, up 2 and over 1, down 2 and over 1. Notice one of the x-intercepts is on the slanted
How is it,
asymptote.
how do you know that it's slanted? I'm confused now.
How do I know it's slanted?
Yeah.
Because the bigger exponent is on top, so you can take the top divided by the bottom one, and you get that
So I go
as an
up.
answer there. I think my slant is a little off. Hold on a second. Let's.
You go up 3 by 2, correct?
No, up 2 and over 1, but so like the right here's the intercept. Down 2 and over 1 puts me in that position. I counted too many, so it's right. Oops, right here, and then down 2 over 1. So it's not over that x-intercept. It's just on the left side of that x-intercept.
So wait, what? I put
Okay, so the bottom part here looks like that. Oh, it should be black, sorry. And then there are no x-intercepts anywhere else, so it has to be up top. That's what that looks like. There will be no curve on the test. Do this problem. If you, like I said, if you don't try, there's no help.
There's only like 5 parts to this chapter.
Yeah.
Oh, I know.
Ugh. All right, so on the x-intercept, you set your numerator equal to 0. It's the sum of cubes. And when you do that, you get the x plus 1. So x equals -1 is your x-intercept. And you have a trinomial. Doesn't factor, so you put it in the quadratic formula, and you notice you have the square root of a negative. So that's just imaginary. So you're not going to be... The -1 is the only x-intercept that you have.
But you would like to show the imaginary on the test, correct?
Well, you can go this far, and that's fine. And then y-intercept's there, vertical asymptote. You take your denominator, set it equal to 0. It's the difference of squares. And then we have the horizontal, which you have the higher exponent on top than the bottom, so you have to do long division. So we set that up. Okay, so x cubed over x squared is x. So I'm going to put just a couple placeholders in here. We don't need them all. So x is our answer that we want. You have to distribute that through. You get x cubed minus 9x. And then when we subtract, that gives us a positive 9x. And then again, 9x over the first. And that doesn't work, right? So plus 0. So when we graph this, x-intercept is at -1. Y-intercept's at -1/9. Vertical asymptote at 3 and -3. No, the horizontal is slanted. Okay, so you have, it's going through 0 with a slope of 1. All right. Now, graph. What do you think on the left side? Where are we at?
You'll be going along.
Down there at the bottom, because you don't have any x-intercepts to the left, right? And on the same side on the right, there's no x-intercepts here, so it has to be up in this area.
So, since there's no.
All right, so left to right, hit the first x-intercept, then to the y-intercept, and down, crossing the slanted asymptote in the middle. All right, let's graph this problem. F of x equals 4x over 2x minus 5. Go. All right, here we go. X-intercept is x equals 0. That's also our y-intercept if it's at the origin. Y-intercept, you have 0 over -5, which is 0. Okay. Vertical asymptotes, 2x minus 5 equals 0. So x equals 5/2. Good job. So 2.5. How we doing? Good? Okay. Horizontal asymptote. The leading exponents are the same. So y equals 4 over 2 is your horizontal asymptote. And now graph it, everybody. Okay, what you should have done. You got an x-intercept and a y-intercept right there. Boom. That's what that looks like. There's no x-intercept on the right. So that's where it has to be. Who got it right? All right, excellent, good. 75%. That's a 0. That's an F. That's an F.
Well, I'm confused because I thought it had to be over the plane and not the original.
Yeah.
I may have done something different.
For what?
We're reading this and it's like it's saying.
All right, guys, let's do this. X to the 4th minus 9x cubed plus 22x squared minus 32.
What's this?
You have 4 zeros. I'm going to give you 2 of them.
Oh, I don't remember how to do this.
4 is one of your zeros that has a multiplicity of 2. Use synthetic division to find the other 2. And then, if you can remember by this time, write it all in factored form. All right. 1, -9, 22. You forgot 0.
Yeah, that's what I just realized that I was paying attention.
Drop it down, multiply, add. Multiply, add. Multiply, add. Multiply, add. So yes, it did work. If you didn't get a 0, then you did it wrong, obviously.
Because it has to follow with like a negative.
If I say
Add the,
find the zeros, then obviously these are your zeros. If I don't say, then you don't know if it's going to work or not.
So the 0 will be.
So as you see at the beginning of the videos, there's a couple that don't work.
So the 0 will be.
Multiplicity of 2, so you need to do it again. And there you go. There's your two multiplicities of 4.
That's what I did.
And you have x squared minus x minus 2, which is x minus 2, x plus 1.
Oh, I didn't do that.
So your zeros are 4, 2, and negative 1. And in factored form, that would be x minus 4 squared, x minus 2, x plus 1.
Will it ask us to do it in factor form?
You are so dumb.